Hello students. Let us discuss about the new topic called process management in distributed computing. In a distributed operating system, the main goal of process management is to make the best possible use of the processing resources of the entire system by sharing them among various processes that are involved. Okay, so the management has to be done properly. We have to be sure about in which particular destination node the process has to work. So at times it may happen that we have to shift the process from one machine to another, and in those cases we require process migration, which will be also covered. So three main concepts to achieve this goal of process management are the processor allocation, so which process should be assigned to which processor. Okay, so if you have a process with you, if there is an event that has to occur based on certain code, then in which machine would you want that to happen. Okay, then we have process migration, so movement of a process from its current location to the processor to which it has been assigned. Okay, so maybe a process reside on a particular machine, but however due to the resource demand or due to other maybe due to various requirements, it may happen that the process need to be migrated, and this is one of the very crucial concept related to process management. Okay, and lastly it is thread, where we have parallelism, so it can be fine grained or coarse grained, but fine grained is more preferred, so it means that the process should occur in a particular processor throughout its lifetime, but however it may not be possible. There may need to be some shift of the work from one machine to the other. Okay, so then we come to process migration. It is the reallocation of a process from its current location to another location. So the previous location is termed as the source node here, and the final destination or the another node where the migration will complete is known as the destination node. So here you can see we talk in terms of time. We have two parties involved here. One is the source node and the other is the destination node. So we assume that we have a process called PI and it is in execution. So the process starts and it keeps on executing, but when the realization is made that it has to be shifted, the execution will be suspended and there will be transfer of control. So the entire address space may get shifted from the source node to the destination node, and once all the information has been shifted, the execution can resume in the destination node. So you can see PI continues to execute. It's a very generic scenario here in order to make you understand what is process migration. So this is basically the process migration where the transfer has taken place. So the time when this transfer starts up to the time when it ends is termed as the freezing time. So at this particular time the user may not be able to interact with the process, but we have to bear with that. Okay, then we come to process migration. It can be of two types. One is non-preemptive and the other is preemptive. I think you already are aware of these concepts from operating systems. Well, in case of non-preemptive, before the process starts executing on a source node. Okay, so if a migration has to take place, let it take place even before the process starts. Okay, because once it starts you cannot stop. Okay, it's non-preemptive. But in case of preemptive, during the course of execution of the process, you can make transfers based on the demand that the process has. Okay, which one is costlier and due to what reasons? Well, try to identify yourself. There are two ways we can do it. In the first case, of course, a lot of time will be invested in the beginning itself. In the second case, it may not be so. We only need to wait when certain demand is made from a remote machine. Fine. So then we go to process migration and the various steps that are involved. So the major steps are three. First is selection of a process that should be migrated. So first we select the process, then selection of the destination node where the process need to get migrated due to the resources that require the process to exist in that particular machine, and then actual transfer of the selected process to the destination node. And the third step is the actual activity where the transfer takes place. So desirable features of a good process migration mechanisms are as follows. We need to have transparency. I think this term has been mentioned a lot in the entire course, because transparency is one of the prime features that we require in a distributed system. So then next is minimal interference, and the last is minimal residual dependencies. So these three features need to be available in order to have a good process migration. Okay, so in case of transparency, two things should be maintained. One is object access level, and the other is system call and inter-process communication level. So object access level means minimum requirement for a system to support non-preemptive process migration facilities. So whenever an object is required, it should be allowed, even if it may be in a remote machine. So access files and devices in location independent manner. Okay, in an independent manner. So it means you should be able to fetch information or files from anywhere in the entire network. Then system call and inter-process communication level, so that a migrated process does not continue to depend on its originating node after being migrated. So see, if we transfer a particular process from, say, source node to the destination node, so once it comes in a destination node, we should not have any dependency from the source node anymore. Okay, or we should have very minimal dependency on the source node. So that is what being said here. So and then only we can say that we will have very minimal communication. Okay, then the second point is minimal interference, that is minimum freezing time. So time period for which the execution of the process is stopped for transferring the information to the destination node. Sorry, we need a bracket here to close the statement. Anyways, so here we say that a minimum interference should be there, that is a minimum freezing time, because the more the freezing time, the more the user has to wait for the background activity to complete, and it is not desirable. Okay, then third is minimal residual dependencies, no residual depending on the previous node. Okay, there we should not rely upon the previous node anymore. In the previous diagram, it talks about the source node. Impose load on the previous node, because otherwise it will impose extra load on the previous node, which wants to be free, and that's why the migration took place, isn't it? So we should not again bother that node again. And then failure or repeat of the previous node, and it also may also happen that you want to get some information from the previous node, say the source node, and that machine is off or has crashed or something, then you will not be able to, or the process will not be able to get the desired resources. Okay, so minimal residual dependencies should be maintained. Then we come to three different concepts. One is called total freezing, the other is called pre-transferring, and the third one is called transfer on reference. So students, be very clear about these three concepts. So total freezing is, as you can see this diagram, we have a source node and the process was started and it is executing, and then it was suspended because a migration has to take place. So when this decision is made, the entire transfer of the address space has to be done. So address space is the particular, you can say, resources where all the available data is existing. Okay, so you have to transfer all the information that exists in the address space to the remote machine, which is the destination node. Okay, so entire thing will be transferred, and during this entire time the user has to wait, and so we have the very high amount of freezing time. Okay, so once everything gets shifted to the destination node, then the process can again resume its execution, and as we can see, it continues. Okay, so this is total freezing, that is we totally freeze the entire interaction with the user, and we try to transfer the entire information from the source node to the destination node. Then we come to pre-transferring. In this case, what happens is, once the decision has been made to transfer the particular address space, here you can see that this process is executing, and while executing, because up to this point the process will continue to execute in source node, So even though this process is running, the transfer is also going on because a decision was already made. Okay, so since the activity is going on, okay, and the transfer is going on at the same time, okay, we have a very small amount of freezing time because we only require to have this freezing activity, okay, at the last moment when maybe there were certain changes made during this part of the execution, right? So those updated files can be transferred. Okay, so I repeat once again. So this particular process is running here, and while running, the transfer is also going on. So see, from this point to this point, the transfer is going on. However, it may happen that the process execution has updated certain files which also needs to be shifted. So we ultimately have to stop the execution here, and we also have to freeze it in both the sides. That means the user will not be able to interact for a small amount of time at the end of the migration, because all those files that were updated during the transfer also needs to be shifted to the destination node, right? So that's why we have to have a stopping time when this last few files are shifted to the destination node, and once it is done, the execution can continue. Okay, and the last concept is transfer on reference. I think you already got an indication with it, from this term reference. So here again, with time the process is executing. However, here you can see, yeah, the decision has been made that a particular process will be running in a remote machine in the destination node. So a small amount of freezing time will be required in the beginning. However, after the information has been passed over, the execution can continue in the destination node, and if certain informations are required from the source node, okay, only at that moment transfer will be made. So on-demand transfer of address space. So the entire address space will not be shifted, and that's very cool, right? Because we only need to fetch those information or request those information from the source node which are currently required by the process. So this is good. This is good in terms of what we call the load of shifting gets reduced to a great extent. However, communication may have to be extended to a good amount. Why? Because it may happen that the process require a lot of information from the source end afterwards, okay, after the execution was resumed, right? Then there has to be a lot of communication between the source node and the destination node. So though it looks very straightforward in the beginning, it may happen that the whole network may get overloaded with communication messages. Okay, so we have to be very careful about it. So these are the three concepts. Please go through it properly: total freezing, pre-transferring, and transfer on reference. Okay, thank you everyone.